Alright, so as you saw in that first video, we can see equations and look at the slopes and the y-intercepts and determine if there's one, none, or infinitely many solutions. And so we are going to figure out how many solutions there will be with inspection. So we're not actually going to graph anything here. We're just going to look at our two equations and determine this. So the first one is A, and you'll notice this is not in the form of y equals mx plus b, and so it's really difficult to compare our slopes and our y-intercepts when they're not the same here, or when it's not in that form. So what we actually have to do is change the form into y equals mx plus b from this standard form. So that's what this is called, is its standard form, and we have to make it into slope-intercept form. So over here, I'm going to rewrite it and have my work showing this. So here's the initial equation, and we have to solve it for y. That means we have to get y all by itself because it needs to end up in the form of y equals mx plus b. So I have to move this 2x over. That's a positive 2x, so to move it, I'm going to subtract 2x. If I do it on the left side, I have to do it on that right side. That leaves me with a negative y is equal to, and then I'm going to put the x first because we want it in y equals mx plus b, so we want that x value first, so I'm going to put negative 2x, and then this is a positive 9, so plus 9. So here's my equation, negative y equals negative 2x plus 9. This is not quite done because here I have a negative y, and I don't want it to be negative. So think of this as a negative 1y. So to get rid of it, we're going to divide both sides by negative 1. So that leaves me with y on the left. And then when we're dividing that right side by negative 1, we have to divide every single value by negative 1. So we're going to do negative 2x divided by negative 1, which would be a positive 2x. And then we're going to do 9 divided by negative 1, which would be negative 9. And then this here is in slope-intercept form, and so that is what that equation is equal to. So I'm going to rewrite this one as y equals 2x minus 9. Okay, my second equation was 2x plus y equals 11. We need to get that y all by itself, so I'm going to move this to x. Leaves me with y is equal to, that's a negative 2x and a positive 11. So here's that equation. And so I'm going to rewrite that as y equals negative 2x plus 11. Okay, so here are my two equations. And so what I can do now is I can compare those slopes. Are these slopes the same? No, they're different. 2 is not the same as negative 2. So because these two slopes are different, that means we're going to end up with one solution. Okay. With ending with one solution, we would then have to determine what that solution is. And the way we do this is with graphing. And so if we had a graph, we would be able to say, okay, that would then be our one solution answer of 5, 1. Okay, and I'm not expecting you to get those on this right now. Also on the homework, you aren't telling me what the solution is. You're just determining if it's one, none, or infinite. Okay, and so my explanation here would be is they have different slopes. Which means the lines intersect. Okay, so a graph would look something like that with one intersecting point. Okay, Awesome. B, this already is in slope-intercept form, so we don't have to convert it. We just look at those slopes. We have 1.5 and 1.5. Those are the same. And so because they're the same, we know it's not going to be one solution. And then now we're going to look at our y-intercepts. We have a positive 9 and a negative 9. These numbers are different, and so because these are different, we would end up with an equation of 9 equals negative 9. 9 does not equal negative 9. It never will, and so this is no solution. So remember, if the slopes are the same, but the y-intercept is different, there's going to be no solution. So they have the same slope, but different y-intercepts. So they'd be parallel. Okay, and this is because if I were to graph this, I would have one line like this, and the other one would have the same slope, so it's the same steepness, but it has a different y-intercept, so they would run parallel to each other. And because they're parallel, they would never intersect, therefore they would be there would be no solution. Okay, awesome. Next one, C. These are not in slope-intercept form, so we have to change it. So the first one, negative 4x plus 8y equals negative 16. We have to get this y all by itself. So I'm going to move the x. That's a negative 4x, so I'm going to add 4x. Leaves me with a positive 8y is equal to, I want the x first, that's a positive 4x, so I'm just going to write 4x, and then minus 16 because it was a negative 16. And then the y needs to be by itself, so I'm going to divide both sides by 8. On the left side, that leaves me with y, and on the right side, I have to divide everything by 8. 4 divided by 8 is 1/2, so I'll have 1/2 x, and then negative 16 divided by 8 would be negative 2. Okay, so this first equation would become y equals 1/2 x minus 2. Okay, with the second equation, negative x plus 2y equals negative 4. We need to solve for y. So I'm going to move the x, so I'm going to add 1x to both sides. Leaves me with 2y is equal to, I want the x first, so that's a positive x and a negative 4. And then I'm going to divide both sides by 2. That leaves me with y is equal to, on that right side I need to divide everything by 2. This x has a 1 in front of it, so that's 1 divided by 2, or 1/2 x. And then negative 4 divided by 2 would be negative 2. So this would give me y equals 1/2 x minus 2. Okay, what do you notice about these two equations? I hope you thought that they are the same, and so this, because they're the same, that we're going to have infinitely many solutions. Okay, they have the same slope and the same y-intercept, so they will be the same line. So if I were to graph this on my graph, it would just be one line. Every single point on that line would be a solution. That's why there's infinitely many solutions. Okay, and that last one, this is not in slope-intercept form, but we can look at this and see that most of it is all the same. Like this 7x and this 7x, this 3y and this 3y. But then these two are different. And so I can say, okay, well, the number with the x is going to be the same, but the number without the x will not be the same. And so that's just like what we saw earlier right here. This would be no solution. Okay. And the reason is same slope, different y-intercept. So parallel lines. And again, the reason I see this is if I look at these x's, they're the same. These y's are the same. So that means that my slope is going to stay the same, but then I notice that that number without any variable is different, so they're not going to be the same. Okay. Awesome. So go to page 11. The first equation is a system, and we need to rewrite the equation in slope-intercept form and then determine the number of solution it would have with each equation that's given. Okay, so like it says, the first thing we have to do is put it into slope-intercept form. So we have to move our x. This is a positive 3x, so I'm going to subtract 3x on both sides. Leaves me with a positive y is equal to, that's negative 3x plus 6. And so here's my equation. And then we're going to use that to determine if there's one, none, or infinite. So A says y equals negative 3x minus 6. We first look at those slopes. Are the slopes the same? Yes, they are. They're both negative 3. And then we're going to look at the y-intercept. Those y-intercepts, are they the same? No, they are not the same. One is positive and one is negative. Therefore, those are not the same number. So that's going to be how many solutions, class? I sure hope you said none. This would be no solution. Okay, the next one, first thing we do is we look at that slope. Are they the same? Negative 3 and 3. Are they the same? No, they are not. And so because they're not, we just stop there, and this is going to be one solution. So remember, if the slopes are different, it's one solution, period. And generally, you would then solve to figure out what that one solution is. Okay, and then C, we look at those slopes. Are they the same? Negative 3 and negative 3. Yes, they are. And then we look at those y-intercepts, a positive 6 and a positive 6. Are they the same? Yes, they are. And so because this is the exact same equation, there will be infinitely many solutions. Alright, I want you to please pause the video. You are going to complete number 4 on your own, so you have to first convert that given equation here into slope-intercept form, and then determine if A, B, and C is 1, none, or infinite. So pause. Alright, so when we did this, we should have moved that negative 12x by adding 12x. That gives us 6y is equal to a positive 12x minus 30. Then we would divide both sides by 6. That left side becomes y, and the right side we have to divide everything by 6, so 12x divided by 6 would be 2x, and negative 30 divided by 6 would be negative 5. Okay. Snaps if you got that equation. Awesome, so then that's the equation that we're going to use. And A, class, how many solutions? One solution. B, how many solutions, class? Infinitely many, because it's the exact same equation. And C, how many solutions, class? Good, no solution. Because slope is the same, but the y-intercept is different. Awesome. So again, you'll notice we aren't graphing these, but we're able to determine if there's one, none, or infinite because we are inspecting it. That is why this lesson is called Solving Systems by Inspection. Okay. Alright, in 5 to 7, the first equation is a system given. We need to write a second equation that would create a system with the given number of solutions. So number 5, it's already given in slope-intercept form. We need to create a second equation that would give us no solution. So I want you to turn to your partner. What is the same and what is different if we're trying to get no solution? Turn and talk. Go. Awesome. So for no solution, we should have the same slope, but a different y-intercept. So if it was y equals negative 1x plus 10, we would need the same slope, so y equals negative x, but we need a different y-intercept. So this could literally be any number besides positive 10. So I'm going to say positive 12. We could have said negative 10, we could have said 13, we could have said positive 6, we could have said negative 7, okay, any number besides positive 10. Awesome. Infinitely many. You're going to turn and talk to your partner and you're going to explain what the equation would look like regarding slope and y-intercept if we're looking for one that would be infinitely many solutions. So turn and talk, go. With infinitely many, this should be the same slope and the same y-intercept. So if it's the same slope and the same y-intercept, we could have the exact same equation. Or we could have one that was in standard form, meaning it's not in slope-intercept form, and we could have 3y equals negative 3x plus 30, because if we were to solve that for y, we would end up with y equals negative x plus 10. Okay. Awesome. We're going to move on to number 6. So we need to first put it in slope-intercept form, so we need to get that y by itself. So we're going to divide both sides by 2. That leaves me with y equals, we need to divide the entire right side by 2, so that's negative 8x divided by 2, which would be negative 4x, and then a positive 6 divided by 2, which would be a positive 3. So here's my equation. We need no solution. As we saw in the previous, that means same slope, different y-intercept. So we could have y equals negative 4x, and then plus or minus 5. Again, we could have literally any number besides plus 3. Okay, so we could have plus 7, plus 12, plus 100, minus 6, minus 12, minus 15, anything besides plus 3. Okay, and then infinitely many, we would have that exact same equation. Okay, awesome. And the last one, we need to get it into slope-intercept form, so we're going to move our x first. Leaves me with a positive 3y is equal to negative 4x, and that's a positive 9. Then we're going to divide both sides by 3. Leaves me with y is equal to negative 4 divided by 3 would be negative 4/3 x. And then positive 9 divided by 3 would be a positive 3. Okay, so this is the equation I'm going to use. And I need no solution. So take a moment, write an equation that would be no solution and an equation that would be infinitely many. Alright, so none could be y equals negative 4/3 x. Everyone should be that exact same, but this last part would be different probably. It would just be anything besides plus 3. So it could be plus 12, plus 6, plus 2, or minus 7, minus 3, minus 12. Okay? And then infinitely many would be the exact same equation. Okay? Awesome. And then we're not going to do this last part of the notes. Okay, so your homework is on page 12, solving systems of equations. Some of these are given in slope-intercept form, some are not. So you need to make sure that, like for A, this second equation, you have to write that in slope-intercept form first. So then you can compare your slopes and your y-intercepts. You can use the back side of this homework page as your work page to do what I did right here, like to show all this work. Okay, so you can use the back side of page 12. Make sure you input your answers into Google Classroom when you're done. Good luck!